Okay, so in this week we're going to be digging into probability. So some basic definitions. A simple event only occurs once with only one outcome. So some examples of things that would be considered a simple event would be drawing a single card from a deck of cards, or flipping a coin, or rolling a dice once. So it says write the sample space for the following simple event. Flip one coin. This is very simple, but what can happen when we flip a coin? We can either get a heads or a tails. Now when we say list the sample space, we list all the outcomes possible, and then we will put them in these little brackets that we call set notation. Another example is rolling a die that has 6 sides and then tossing a coin. This is not a simple event. Why? Because this is not only happening once, and you can see that there's actually 2 things that are going to be happening with our outcome. We're going to have a result from rolling a die, and then a result from tossing a coin. Sometimes it might be helpful to use a probability tree to be able to see all the events. So when you take a look at the first event, it's rolling a 6-sided die. So we're going to use a tree to indicate all the possible outcomes from that first one. So when I roll the die, the possibilities are I get a 1, 2, 3, 4, 5, and then I need one more branch over here, 6. So you can see those are the first event, right? And then I'm going to toss a coin. How many possible outcomes are there from tossing a coin? Well, there's 2. So this is kind of tough for people to get an understanding of, but since it's the second event, we're going to have a branch coming from each of the previous outcomes. And then what happens when we flip a coin? We could get a heads or a tails. So I'm going to fill a heads and a tails in under each of these bottom branches. Now this is just the tree. So after I get the tree created, we're going to need to look at every single one of these branches. You can see we can count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're going to have 12 different outcomes in our sample space. So we're going to need to make some big brackets over here. And the first thing I could get is a 1 and an H, and then a 1 and a T. 2 and an H, 2 and a T. Why don't you take a second? I'm going to hit pause on the video. You go ahead and write the rest of the sample space out, and then check what I compared to what I have, and make sure you got the same thing. All right, so now that you've got this all written out, you can take a look, and you can see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different outcomes right there. And those correspond with that tree that we have written over here. So please know if it asks for a sample space, you need to list the whole thing out. If it just asks for the tree, you can draw the tree. All right, so now let's get into some probability. This next problem says, what's the probability that you flip a coin and it lands on heads? Well, when we go up here, we see here's our sample space for flipping a coin. How many outcomes are there? The number of outcomes goes in the denominator of a fraction. And then take a look, how many of them are heads? There are just 1 that are heads. So the probability that you flip a coin and it lands on a heads is 1 out of 2. It's pretty intuitive for these easy ones, but if we don't understand these easy ones, it's going to get a lot harder very quickly. Please also know that just like everything else we've done previously, anytime you see a fraction, we could also represent that as a decimal, so that would be 0.5, or that could be written as a percent, as a 50% probability of flipping a coin and getting a heads. All right, so now we're going to take a look at the probability of rolling a die. So I've got the sample space written out here. This is the probability. This is a simple event because you can see I can either get a 1, 2, 3, 4, 5, or 6. This says what is the probability that you roll a die and it lands on a number greater than 4. Now remember, greater does not include, so these are the different numbers that we could get when we roll a die and get a number greater than 4. It's either a 5 or a 6, right? How many total outcomes were there? There were 6. And how many of them were greater than 4? There were 2. So the probability of rolling a die and it landing on a number greater than 4 is 2 out of 6, or 1 out of 3. Remember that we could also write that as 0.3333. This is going to repeat forever. We might round that off at some point. Or 33.33 repeating percent, right? So again, we would round those at some point. This says, what is the probability that you do not roll a number greater than 4? Okay, so we could go count the numbers that aren't greater than 4, but this this gets to a concept that's really important in probability, which is called the complement. So the complement. The way I think about the complement is just what's everything else. So if the probability of getting a number greater than 4 is 1 out of 3, the probability that you don't get that is everything else. One nice way to find the complement is 1 minus the probability that that thing does occur. So what is the probability that you do get greater than 4? So that would be 1 minus the probability that we get a number greater than 4 is 1 out of 3. We can use our calculator to find this, remember, either by subtracting the fraction using a TI-30 or a TI-83. I know that 1 minus 1/3 is 2/3. Again, if you go up and look at our sample space, you could have done it just straightforward, but we could have just said how many numbers are not greater than 4. It's these 4 out of 6, which is 2 out of 3. Again, easy to tell with a very simple one, but there's going to be problems later where we're going to want to do that idea of a complement, especially if we have percentages. All right, a couple more examples. This game has a spinner numbered 1 through 25. It says find the probability of getting a 3 or a 6. Well, how many 3s are there? There's only 1 3 in this list, so the probability of getting a 3 is 1 out of 25. The probability of getting a 6 is also 1 out of 25. And then I want to find the probability of getting one or the other. Or is a key word. Usually or means add. So a 3 or a 6, we're going to do 3 is 1 out of 25, getting a 6 is 1 out of 25, so we'd add those together and we'd get 2 out of 25. You're going to see that we're going to favor percentages a lot with these basic probabilities. We will use percents and percentages later, but with these really simple ones, just getting a nice fraction is sometimes some of the easiest ways to represent this. Now, the next problem's a little bit more complicated, but it says find the probability of getting an even number or a multiple of 3. So when we take a look at them, I'm actually going to use some highlighter. Let's get our even numbers. So that'd be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24, right? Now we need to count those up. How many of those were there? There were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 25 of them were even numbers. So the probability of getting an even number would be 12 out of 25. Let's find the probability of getting a multiple of 3. I'm going to use a red pen and I'm going to circle that. So let's circle our multiple 3's. 3, 6, 9, 12, 15, 18, 21, 24. All right, so how many of those were there? Well, we can go through and count. There were 1, 2, 3, 4, 5, 6, 7, 8 of those. So the probability of getting a multiple of 3 is 8 out of 25. But we've got an issue here. What you see is there are actually a few numbers, this one, and this one, and this one, and this one that were actually overlap, right? Those are the ones that are multiples of 3 and they are even numbers. So while you will add the first two like we did in the previous problem, we need to subtract that overlap. So how many times did we double count? You can see that there are 4 of those. So we do minus 4 out of 25. So this is how we're going to calculate this probability. I'm actually going to use my calculator for this one. So one nice thing about these is the denominator remains the same throughout these, and one thing hopefully you know about fractions is if the bottom's the same, you can just combine those top numbers. So I don't know why this minus sign is not showing up, but it's going to be 12 plus 8 minus 4 gives us 16. So the probability of getting an even number or a multiple of 3 is 16 out of 25. And actually, if you go up here and you count them, and don't count them double, there's actually 16 numbers either circled or highlighted. All right, and then the last thing we're going to do today, we have a chart right here that says the following table shows the results when a random sample of musicians were asked how they learned how to play their instruments. So you can see like this is the number of females who are self-taught right here, and it provides us the totals around the corners. If you don't see totals given to you when you start a problem, you're going to want to get those filled out. So the first problem says, what is the probability that a female was self-taught? This is kind of tricky, but since it says we just want the females who are self-taught, how many females were self-taught? There were 12 of those, right? And then we're going to divide that just by the total number of females, which is 72. So an easy way to take care of this is this does simplify. We can use our calculator by just doing 12 divided by 72. And then if I hit math, enter, it reduces that fraction to 1/6 for me. It's just a quick way to go ahead and take care of simplifying fractions. So we said that was 1/6. If you have a TI-30 or another type of calculator, what you're going to be looking for is you're looking for that ABC button. You can just type in 12 and then ABC 72, and that should reduce that fraction for you. All right, the next problem says, what is the probability of selecting someone who studied in school or someone who was self-taught? This is a lot like that dice example, so why don't you take a second and hit pause and see if you can think about it, and then check to see what I got. All right, so we're going to want to do somebody who was studied in school. So there were 62 totals of those, right? So it's going to be 62 out of 130. And then we're going to want to add, because I see that special word or someone who was self-taught. So our self-taught people, there were 31 of those. So 31 out of 130. There isn't any overlap here, right? You see that we have self-taught, we have studied in school. There's no overlap, so we don't have to worry about that. So we can just add these up. 62 plus 31 is 93 over 130. I don't think that reduces, but again, I'm just going to double check by just dividing those really quickly. 93 over 130. And then again, I hit that math, enter. And that does not simplify, so that would be my final answer. All right, the last one, this is going to be the trickiest one that we're going to see in this table, but it says find the probability of selecting a male or someone who learned from private instructors. So what I'm going to do here is, when you take a look, we're going to find the probability of selecting a male, which is going to be 58 out of 130. And then we're going to add someone who learned from private instructions. Where are those people? The private instruction people is going to be this right here, right? So how many of those are there? There are 37 out of 130. All right. And finally, you just, oops, I should not have hit equal there because we want to check. Take a look and see, is there any overlap right there? You can see right here at this 15 was counted twice, wasn't it? You can see that that number was both circled here and it was highlighted across. So that's going to tell us what we need to subtract at the end. So we need to subtract the overlap, which is 15 over 130. That will get us to our final answer. So we're going to do 58 plus 37 minus 15. Which is going to give us 80 over 130. And again, if it's ever even numbers, we know that these are both even numbers, so we can divide those. So I'm going to simplify that by doing 80 over 130, and then hitting math, enter. And it's 8 over 13 is going to be our simplified fraction.